Advanced Math Lesson 19, Part B. We're going to continue on with our factoring of exponentials. And we already did example 19. Let me fix my camera. We already did example 19.4 in the previous video. We're going to go with 19.5 because you can't always tell that you need to factor these simplified problems. And it's kind of like a trick and that they tell you to simplify, but they don't tell you that you need to factor it before you, so you can simplify it. So let's get started on this. I'm going to use magic to make the problem appear on the page. Ta-da! I'm gonna laugh when I look at this video later and I see how much the video skipped. Let's see here. So they just tell us to simplify this problem, but we actually have to factor the exponentials to simplify this problem, because you'll notice that we have a polynomial in the numerator and a polynomial in the denominator. We can't just simplify like this, because then it breaks the rules of polynomials. We can't just do that when there's a plus or a minus sign. So what we have to do is we actually have to factor the numerator. So again, factoring the polynomial, we have to look for the greatest common factor. In order to do that for this problem, we have to remember a little something from Algebra 2 called difference of two squares theorem. And what that said was, if we had a polynomial that was two squared numbers being subtracted, those could be factored into, and you might have been seeing these on your problems lately, or maybe that's Algebra 2. That's all right. So this difference of two squares, or two squares being subtracted, can be factored into this. Each individual term in the first parentheses being added and in the second term being subtracted. So we're going to use that to apply here, because another way to rewrite x to the 2a and y to the 2b is we could rewrite it like this: x to the a squared minus y to the b squared. And that just helps you visualize it a little bit better. But if you're really good, you can catch that just by looking at it up here. Excuse me. So once we can visualize that this is a difference of two squares, all we do is we take the first term, or each term, and we put them together being added, and then we group them together being subtracted. So now we have x to the a plus y to the b, x to the a minus y to the b, and that's our new numerator. We take that and we put it over our denominator of x to the a plus y b. Now we can see we can factor because we have the exact same polynomial on top and bottom, so we can cancel those out, which means our final answer is just going to be x to the a minus y to the b. Okay, now the key to some of these, especially these fractional simplification problems where you have to factor exponents, is you got to memorize this difference of two squares problem right here. You just got to know whenever you see two numbers squared being subtracted, you can rewrite them like this. Now that's a good segue into our next lesson, which is sum and difference of two cubes. And that gives us two similar ideas that we see here on this page. The first one is that once we have, actually this might work out better if I construct it on the paper. The first one is sum of two cubes. By cubes, we're talking about numbers to the third power. So if we have a cubed, I'll put a line here, separate that, a cubed plus b cubed, that can be factored into a greatest common factor and a polynomial, or well, a quadratic polynomial. So what's going to be in the first one, if it's positive, is we're going to have a plus b. Now the quadratic in here is going to be a squared minus ab plus b squared. And these are really interchangeable. I mean, we could have put b plus a, we could have put b squared minus ab plus a squared. But if it's positive, know that this first polynomial is going to be positive. And then you'll have a quadratic with a minus and a positive. Now, if it's negative, a cubed minus b cubed, so this would be the difference of two cubes, what you get is the first polynomial is actually negative. It's a minus b, right? So that should be pretty easy to latch onto. Positive, a plus b, negative, a minus b. And then you're going to have a quadratic again. It's going to be in the form of a squared, ab, b squared. But this time, all of the signs will be positive. All right? So the key thing to keep track of is the format, which is a plus b, and then a quadratic of a squared, ab, b squared, and then the signs. So if it's positive, the first sign is going to be positive. If it's negative, the first sign is going to be negative. After that, the very next sign switches, and then the last sign is always positive. So these are two differences, or two. Let's see here. What do they call them? I don't think they're called theorems, but these are two cases that you'll have to memorize and be able to recognize when they're applied in your homework. So let's go ahead and use an example. We got time. We'll do two examples because this is going to be pretty tough. And, I'll use a separate sheet of paper so I can keep coming back to these two theorems. So the first example gives us x cubed y cubed minus p cubed. So you immediately notice we have cubed elements and a subtraction sign, so this is going to be difference of two cubes. In this case, the a element is going to be xy. So we would say that xy is going to be equal to the a element, and then p is going to be equal to the b element. From there, we just have to plug them in with this this formula that we've memorized. So the first term is going to be, let me find a way to set this up. There we go. Yeah, that works. Okay. So the first term is going to be a set of parentheses, and then we'll have xy minus p, right? So we're sticking with the rules here. Then the next one is going to be a quadratic. The a squared would be x squared y squared. The ab that we're adding would just be xyp. Remember, all to the first exponent. And then the last one, b squared, would just be p squared. And that's it. That's the difference of cubes. That's our answer. So once we get these down, it's a really easy formula to apply. We'll go ahead and do the same thing, and we'll use a positive example. Now the positive example they give us is 8m cubed y to the power of 6 plus x cubed. And you'll notice they like to complicate the a term. And in this case, we have a whole number in the a term. And if you know your two times tables, you realize that 2 cubed is equal to 8. 2 times 2 is 4, times 2 is 8. So the base, or this 8, could be rewritten or thought of as being a 2 cubed. And so anytime you see a number like this and they tell you to factor it, try to find the cube of the whole number. They might use big ones like 64 or 125. Always try to find the cube of whatever that number is. So without further ado, we'll go ahead and plug this into our equation. So since it's positive, the first term is going to be positive, so we'll have 2my plus x, and that satisfies the a being 2my, the b just being x. And then we plug in our a squared, so 2 squared is going to be 4. And then we have m squared y squared. Then we're going to subtract the a times the b, which would be 2my x. And then lastly, we're going to add the b squared, which is just going to be x squared. And that's our answer. So difference of cubes isn't too hard. We just have to do a little bit of memorization. And that memorization being these two difference of cubes formulas. And that's it for lesson 19.